This example of the LeChatelier's principle will illustrate a few of the, not exceptions, but slightly trickier scenarios you'll come across. So first off, as a refresher, if I add sodium to this system, we'll probably think that, yeah, it's going to turn left. You're going to be right. Okay, if I add more sodium, I'm going to shift to the left. If I add more chloride, I'd also shift to the left. So then conversely, if I add more sodium chloride, solid sodium chloride, I can shift to the right. Well, that's not true. Remember, if I add a solid substance to an already saturated system, well, you can picture it as we've got our solid sodium chloride down here, we have sodium ions, we have chloride ions. If it's saturated, this solid ball of salt basically remains constant. So if I add more solid salt to this beaker, if I put more in, then it's just going to sink to the bottom. Nothing's going to happen. So that holds true when you're analyzing LeChatelier's principle scenarios. If I add more pure solid to this system, nothing is going to happen. Okay, and the same could be said for pure liquids. Okay, for a heterogeneous system. What does that mean? If there are different states involved, so if you've got aqueous, some combination of aqueous, liquid, gas, solid, do not include pure solids or pure liquids. You'll see that later on when we calculate K as well. Okay, so add sodium chloride, solid sodium chloride, nothing happens. Okay, so that's one scenario. Now how about if I add some sodium nitrate to the system? Well, first inclination might be nothing happens, so I don't have sodium nitrate in there. Remember, this is an ionic compound, and it's a soluble one. So when I add a solid sodium nitrate, or any soluble ionic compound, first thing I'm going to do is dissociate it into its two ions. So now I have sodium and I have nitrate. You'll see nitrate a lot because it's pretty unreactive. But nitrate's not there, but sodium is. So by adding more sodium nitrate, that is essentially the same as adding more sodium ions to the system. So if I add more sodium ions, well, I'm going to shift left. Okay, well, how about if I add more or a sample of silver nitrate? Okay, same thing. Ionic compound, soluble, so let's dissociate it. Now in this example, neither ion is present in the equilibrium system. I have silver and I have nitrate. Again, nitrate's pretty unreactive, so won't deal with that. Rarely will we ask you to add a compound to a system that is going to have no effect. So what I'm going to have to do is look at some reacting entities. Sometimes it can be adding an acid to a base or a base to an acid to change pH. In this case, we're adding one ionic compound to another, and we're going to look at the reaction of my silver and my chloride. So what reaction is that going to be? Well, if I look at my solubility table, reacting silver with chloride will produce a solid silver chloride precipitate. It has low solubility on your with your chloride ion. Okay, so as a result, what's happening to this chloride? As I add silver nitrate to this system, that silver is reacting with that chloride, and as a result, it's removing it from the system because we're making more and more of this silver chloride as the reaction proceeds. So if I add more silver nitrate to the system, silver reacts with the chloride, it's going to shift to replace that missing chloride, therefore shift right. And you'll see an example of that in the lab you do. Now, LeChatelier's principle can also be related to color changes. Sometimes your reactants and products will have specific colors associated with them. So if it shifts to the left, it will turn, pink or blue or green, depending on the substance. In this case, these are all colorless. Okay, you'll see some examples of that in your first lab, and in your textbook as well.